come up with another very important topic of mechanics: static friction. See the following images carefully. They depict that the associated bodies are intended not to slide along the surfaces they are in contact with. The child does not want the spoon to slide through his curved fingers. The cyclist will go nowhere if her bicycle wheels slide at the same spot. The weightlifter will never even go into the nightmare of the barbell slipping through his palms. A man will find it difficult to walk or trek if his feet slide backward. Yes, but for static friction, we would find no body static relative to the surface it is in contact with. What is static friction? Static friction is a self-adjusting force existing between two surfaces to prevent them from sliding relative to each other when they actually tend to do so because of some other forces acting on it. In the diagram, capital F is the force that tends to make the object slide along the surface. Small fs is the force of static friction balancing the force that tends to move the object along the surface. The force that tends to move the object along the surface is increased. The force of static friction is self-adjusting, and it also increases to balance that force. Thus, when the force tending to move the object along the surface is increased, the force of static friction increases automatically to cancel that force, of course up to a certain limit. This is the limiting force of static friction, the maximum possible static friction between two surfaces in contact under given circumstances. What would happen if the net force tending to move the body along the surface becomes larger than the limiting force of static friction? Simply, the object will accelerate and slide along the surface. The static friction will no longer exist. The normal force is the force that the surface exerts on the object in the direction normal to the surface itself. And the limiting static friction is directly proportional to the normal force. The larger the normal force, the larger the limiting force of static friction. Thus, the limiting force of static friction is equal to the proportionality constant times the normal force. Then we can define the coefficient of static friction as the limiting force of static friction when the surface exerts a unit normal force on the object. Now, let's get familiar with the term the angle of friction. The angle of friction is the angle between the normal force and the resultant of the normal force and the limiting force of static friction. From the diagram, we find the tangent of the angle of friction is equal to the ratio of the limiting static friction to the normal force, and thus the tangent of the angle of friction is equal to the corresponding coefficient of static friction. What is the cone of friction? The cone of friction is the cone formed from the rotation of the resultant of the limiting static friction and the normal force through 180 degree above the normal force. Let's get introduced to another term, the angle of repose. The angle of repose for an inclined plane and an object is the maximum angle of inclination of the inclined plane for which the object can rest on the inclined plane relative to it. Let the angle phi be the angle of repose for the object of weight W resting on the inclined plane with the corresponding coefficient of static friction being mu s. limiting force of static friction in the direction up the incline. The normal force is equal to the component of the object's weight in the direction normal to the inclined plane. On the other hand, the limiting force of static friction is equal to the component of the object's weight in the direction along and down the incline. Thus, the tangent of the angle of repose is equal to W sin phi divided by W cos phi. Hence, the tangent of the angle of repose is equal to the coefficient of static friction. Hence, it is also proved that the tangent of the angle of repose is equal to the angle of friction.